Good morning, all. We were discussing NFA and DFA, that is deterministic finite automata and non-deterministic finite automata. We had concluded that if a non-deterministic finite automata is there, it is always possible to find an equivalent deterministic finite automata. Meaning, can we convert an NFA to a DFA? Yes, we can convert a NFA to a DFA. Now this here in this slide we mentioned how to differentiate NFA and DFA. DFA has exactly one transition for every symbol. DFA does not have epsilon transitions. NFA has multiple transitions for same symbol. NFA has epsilon transitions, and in NFA some transitions may be absent. So now let us in today's video focus on conversion of NFA to DFA. We'll directly go to the problem. So let us have a look at this. This is an NFA, non-deterministic finite automata. So why it is an NFA? Because same symbol A is having two different transitions. Now this NFA needs to be converted into a DFA, and this is a 5-tuple machine having Q, sigma, delta, Q0, F indicating Q indicating set of states, sigma indicating the alphabet, delta indicating the transition, Q0 indicate the initial state, and F indicate the acceptance state or final state. What is the value of Q0? S. What is the value of F? QF. What is the value of capital Q? S, Q1, Q2, QF. What is the value of sigma, A and B? So like this. Now let us have a transition table here. As you can see here, delta transition we are recorded in this table. The symbols are A and B. S, when the input is A, it will go to S as Q1. So this is the next state. S, when the input is B, the next state is S, right? Similarly, Q1, when the input is A, nothing. Q1, when the input is B, it will reach to Q2 state. Now Q2 input is A, nothing. Q2 input is B, it will reach QF. So QF, so both null. Now here, what is our objective? Our objective is to convert NFA to DFA. So what will be the first step here? The first step here will be to keep the first row of NFA as it is and put them in square brackets. This is the convention, okay? So this is the first row, S, S comma Q1, S. So we are keeping this in square brackets, okay? Now the next state, which is not the present state, is S comma Q1, okay. So we have to find out the transition for S comma Q1. Now for S comma Q1, delta of S comma Q1 will be delta of S comma Q1 comma A, delta of S comma Q1 comma B. Delta of S comma Q1 comma A will be delta of S comma A union delta of Q1 comma A. So what is S comma A? S comma A is again S comma Q1, okay? And what is Q1 comma A? Nothing, null. So that's why delta of S comma A is S comma Q1 and delta of Q1 comma A is 5. So it comes to S comma Q1. Similarly, what is delta of S comma Q1 comma B? So S comma B will be S, Q1 comma B will be Q2. So S and Q2 will be the output. So we have S and Q2. So S comma Q2. So these are the two states. So what was our first state? S. What was our second state? S comma Q1. For S comma Q1, what was the output? S comma Q1 and S comma Q2. So first state was S. The second state was S comma Q1. So what is the next state? S comma Q2. Next state, which is not a present state, is S comma Q2. So again, S comma Q2 comma A, S comma Q2 comma B. So S comma Q2 comma A, let us see what happens. S comma Q2 comma A, S comma A will be S only, Q2 comma A will be nothing. S comma A is S comma Q1, Q2 comma A is nothing, so it will be reaching S comma Q1 only. So S comma Q2 comma B again is getting S and QF. So we have this S comma QF final state. So again we'll be adding this in the row. So S comma Q2, the output is S comma Q1 and S comma QF. Now what is the next state which is not the final state? The next state which is not the final state is S comma QF. So delta of S comma QF comma A will be S comma A union QF comma A. S comma A is S comma Q1 and QF comma A is null, phi, and S comma QF comma B is delta of S comma B union delta of QF comma B leading to S union phi leading to S. So if you look at this result, the result of this first transition is S comma Q1, which is an old state, and the next transition is S, which also is an old state. So both are old states now. Both are old states. So that's why this is our transition table. So now this you can represent in the form of a tuple also. What is the value of Q here? S comma Q1, S comma Q2, S comma Q, like that. What is the value of sigma? A comma B, like that. So this is how you are going to convert your NFA to DFA. Let us quickly have a this is how you represent your DFA again. Okay, this is the table, this is the value of Q, this is the value of F, and you see here F. Hopefully you are able to follow this. Thank you.